So welcome to today's instance of the Antrea community meeting. Today is Tuesday, March the 2nd, or well, still Monday, March the 1st if you are in the United States. And for today, we have two topics in the agenda. The topics are, and not necessarily in this order, kube proxy removal design for Linux, and Wei Chang and Hong Liang will introduce this design. Then we have a demo about the flow aggregator, and this demo will be given by Srikar and Io. We don't have a strict order, and therefore I would like to ask you whether Srikar and Io would like to go first, or whether instead you want to first discuss the design of the kube proxy removal. If you don't have any preference, I'll pick a random one. I'll wait 10 seconds to express if you have any preference.
We don't have any preference. Yeah.
Sounds good. So I will say, let's keep the demo, which is usually lighter and nicer, to the end. And let's start with reviewing the design proposal for the removal of the kube proxy. Does that sound good to you?
Sure.
Perfect. So I don't know who's going to present, either Wei Chang or Hong Liang, or both of them, but please go ahead.
Okay, so we start. Hello, everyone. This is a presentation about the design of replacing kube proxy, and it's Linux only, not including Windows. Here's the outline. There are three paths: motivation, work items, design. First, the motivation. If a kube proxy is removed, the implementation can save a lot of CPU cycles and memories, and the entry proxy takes all charge of service traffic, and we can have more control over service traffic. We still need the following abilities to do the replacement. First, during the installation, the entry needs to access to Kubernetes service towards resources. Thus, some components in entry needs to able to access to Kubernetes API server directly. Second, the ability to serve cluster IP service on host node. Entry proxy does not have the ability yet. Third, since entry proxy will take all charge of the service serving, service will not be available until the first sync of entry proxy. So we need to make sure our sub components rely on service to be waiting until entry proxy is ready. Fourth, some options should be compatible with the kube proxy. The kube proxy may not exist when we are installing entry in the future. This will make services not work during the installation. Meanwhile, entry needs to connect to the Kubernetes service towards resources. To overcome this issue, entry agent and the entry controller should be able to access to the Kubernetes API server directly. In the current implementation, we use the in-cluster kubeconfig to set up the connection of the Kubernetes client. In the replacement design, we need to change the server address from the service address to the IP address connecting to the Kubernetes API server. There is a PR 173 file for supporting this in entry agent. We also need a similar PR for the entry controller.
Sorry to disturb you. I know you have an item that you will rearrange the bootstrap order of components in entry agent, right? Because they rely on the service availability. But could entry controller depend on the entry agent serviceability as well. We could first let entry agent start, then entry controller can continue use this service address to connect Kube API server.
I'm sorry.
I mean, you have an item that it says components in entry agent will be their bootstrap order will be rearranged, right? So that
yes.
other services, other modules that rely on entry proxy will start after that. So I mean, could this apply to entry controller too? Because entry controller can rely on entry agents to provide this service access, so that it doesn't have to connect to the API server using the IP address.
Okay. I got what you mean.
Would upgrade work in this scenario? Because I remember we always upgrade Antrea controller first, right?
Let me see. This doesn't it doesn't impact this. I think it doesn't impact the upgrade process, because it still needs. I think entry agent doesn't especially entry proxy doesn't rely on the net policy connection to start, right? So even entry controller is not running, entry proxy can still start.
Okay, I see.
I think entry controller can rely on the service implemented by could be the entry proxy, but entry controller relies on the entry controller connects to Kubernetes API server. Is also okay.
Yeah, I just want to discuss whether there is it is necessary to introduce another configuration to entry controller if this is not a very serious issue. But sure, you can always make it connect to API server directly.
Okay, I understand. Maybe we should just discuss the entry agent part, not including the entry controller part.
Sure.
Will we go?
Sure.
Okay. Next, the entry agent, the entry client and entry agent use the entry service towards internal network policies. And we make the entry client to be initialized after the first sync of entry proxy as the entry service is ready. Okay, next. Currently, before routing to OAS, the service traffic is manipulated by IP table items. These items are under control of Kube proxy. What we expected is that service traffic can bypass Kube proxy and be routed directly to OAS pipeline. Okay, next. Firstly, we use IPsec to match the cluster IP address, protocol, and port. The matching time complexity is O1 since we use an IP set with a hashtag. In Kubi proxy, once a cluster IP is created, the related items will be appended to IP tables, and its matching time complexity is ON. In the Mongo table of IP tables, we created a custom chain that marks packets matching the IP set just mentioned with mark 0xF2. The chain should be referenced in both output and pre-routing chains. We add an IP rule to make the traffic marked 0xF2 go to a specific routing table named Antrea that we added. The routing table of Antrea has only one default unlinked route, which forwards all traffic to entry GW0. The traffic will be processed by OS pipeline later. Note that in OS pipeline table 20, we also need to add a flow in response to the virtual IP's ARP request. In that table, we match the traffic marked 0xF2 and masquerade them. In summary, we can see that first, the traffic is marked in Mongo table. Second, with an IP rule, the traffic will be routed in a specific routing table, not the default routing table. Third, the specific routing table has only one special default route. The traffic is routed to entry GW0 by this route item. Fourth, the packets are masqueraded in that table with entry GW0. In OS pipeline table 41, the cluster IP will be matched and sent to a group. In the group, the traffic will be distributed by loading endpoint IP address to an XM registry. This is the dependency of the subcomponents in Antrea agent. From these dependencies, we can get the bootstrap order. And the last part, further options compatible with Kubi proxy. For the red ones, we consider supporting them in the future. For the black ones, we have alternative options. And we have implemented the green ones. The green ones. All right, any questions?
Could you go back to the IP tables and IP rule page? I can see. Could you go back to the IP tables and the IP rule configuration part? So do we do net help? I think yes. Will the packets be netted in the host network? What will it? What net it does? SNet or DNet?
SNet. The package source address should be masqueraded with the IP address of entry GW0.
Okay, so it's for all traffic or specific traffic?
Specific traffic. Mark with 0xF2.
I mean, it's for all service access traffic or some special service access traffic like hopping traffic.
Sorry, the hopping traffic is from port. Is that I mean the traffic from a pod to its service.
This is from host to cluster IP, right? So the original IP is already the host IP, right? Why do we need a masquerade here?
This is for host to a service IP. This is for host to service traffic.
Yeah. I mean, from local host, right? From
yes.
the.
So this is for return traffic to return to the source host, I guess. Does that make sense?
I think this is from local host and not from remote host, right? This is not for node port traffic.
Sure, but the backend can be a remote node.
Yeah, but this is doing SNet, right?
Yes.
I just mean that the source IP is already this host IP. Why it needs to be masqueraded?
And in your mind, how the return traffic will come back from? I mean, return traffic if the backend is on a remote host.
The destination IP of the return traffic is already the host itself. Right?
And that will go to the host network, but will not go to the open switch. Right?
You mean it will use the node IP, not the gateway IP.
Right.
Really? I think we use the IP route to choose the route, right? It will always use the node IP. I didn't try it, but I don't know how the source IP is selected for this situation.
Probably I should add Hongliang is planned. So
sorry.
Yeah, I don't know.
I think it doesn't matter what the source IP address is, because whatever it is, it will be masqueraded with the entry GW0 the IP address. The traffic the traffic from localhost will be routed by the IP rule, and then it will be routed to entry GW0.
Okay,
Chen.
Yeah.
Hello, this is Ray. So I think Hongliang means that if the endpoint is on a host network, so the endpoint IP is the node IP. So if we do not do the masquerade on the request, the reply packet for the reply packet, the packet will be forwarded to the client directly, and the source IP will not be the service IP. Right, Hongliang?
Yes, that's what I want to see.
Okay, thanks.
The track okay. I think I don't need to set it again.
Maybe my real question is how this source IP is selected when it starts the when the host access the cluster IP service. Why it's always this node IP, not the gateway IP? I think that's I want to figure out. Maybe it's determined by the route table, or maybe it's.
I think that depends on if you bind the socket to the node IP or not. If you don't bind, then the police GW0 IP.
I think I didn't have a test about it, but I think if the destination is the service IP address, I think the host will choose the IP address from the Ethernet, not the entry GW0. But I didn't have a test to. I don't have exactly test.
Yeah, sure. We could test it later if without this SNAT action, whether the source IP will be the gateway IP or the node IP. Yeah.
Okay.
Yeah, I have some experience on the Windows node. So for the Windows, if we don't bind the source IP for our request, the source IP will be chosen to follow a RFC. There's a RFC for the Windows. Basically, it will choose source IP for according to the root table.
Yeah, that's what I mean here, because the root table tells it should go the entry gateway link, right? Gateway 0, sorry. Right.
For the Windows, we will find the nearest neighbor or most match the root table or root rule. And for example, if the desk IP matches the default rule, I think it will choose the node IP and the source IP.
Okay.
Mm-hmm. I think Linux may be some difference, but I think they must be similar.
Okay. Okay, thanks.
I have one question. If we add all these IP table rules and IP rules, do we have to stop Kubi proxy, or even Kubi proxy is running Antrea proxy will still intercept the traffic, the host to service traffic and the load port traffic?
Okay. Sorry.
Yeah, probably. I'm not sure you got my question or not. I can repeat.
Oh, okay, thank you.
Yeah, I mean, once we add this IP table rules and IP route rules, if we don't stop Kubi proxy, what will happen? Will Kubi proxy increment the class IP service traffic, or the traffic will still go to Antrea proxy?
First, I first repeat your question. I think you want to question that if we stop the entry proxy, is that
no? I
what
mean, if we don't stop Kubi proxy,
okay,
what will happen?
And it doesn't matter because we use the insert action before the Kubi proxy IP table items, and it won't be hit in Kubi proxy IP table items.
Got it. Thanks.
Maybe also we need to check whether Q proxy use insert, because if it use insert too, then after restarting itself, it could insert before our rules, right?
Sorry.
Yeah, I have another general comment. Probably we don't need to decide here. But I wonder if we start to add more and more IP table rules, will that be the approach we want to go for the long run, or should we still try to put more forwarding logic into open-with switch? For example, is SNAT thing. Should we try to enhance our pipeline to handle it in open-with switch?
Which one? Which step or?
I mean, for example, SNAT or its routing table thing.
You mean this?
Yes.
This one?
Yes. Because I saw we are adding more and more IP table rules. I start to be a little worried. Finally, we are relying on IP tables too much. Then how could we declare we are open-with switch-based solution?
I think we should better handle the SNAT in IP tables. I don't have a better idea how to handle the masquerade in OVS. Maybe I don't answer our question, but
I think in your case, definitely if we want, we can do in open-with switch for SNAT. But we just need to handle the limitation that you cannot do lighting twice in open-with switch. I think anyway, Ray is looking at some solution for Windows. Maybe we should consider together. Again, I didn't really think through, but since I saw more and more IP table rules we are adding, I started to wonder, should we continue that route? Or we should reconsider to put more logic into open-with switch. Probably we can discuss more offline.
I think the traffic that routed to open-with switch should be with the CRDR of pod IP address. I don't know what will happen if we do SNAT in open-with switch.
I think ideally the source IP should be the gateway IP directly, right?
Chen, only thing that if you bind the socket to the load IP, I don't know what will happen. I think that one will be using the load IP to be the source IP.
You mean it randomly select a source IP, or it always uses the default interface IP?
No, I'm not saying it's what you default. I mean, if you, for example, if you create a socket and bind it to the load IP directly. I know people typically don't do that, but if they actually bind the IP, I think it will be using the load IP to be the source IP. Maybe we can do some experiment to see.
Sure.
And actually a relevant idea is that I think we talked about is that I'm still thinking, could the TC be simpler to redirect traffic? For example, that mean we don't need to add any routes, but if we have a way to redirect traffic directly from the node IP to the open-with switch interface. Yeah, but probably I can also do some experiments and we can talk more offline. I don't really tried anything yet, so I'm not really sure it works or not.
I think is a tool support SCTP also.
SCTP.
Yeah, so service should support 3 protocol: TCP, UDP, and SCTP. Yeah.
TC actually is at a low level. I think it's more like layer 2 level. So probably don't really care about the layer 3 protocol, layer 3, layer 4 protocol.
All right.
Any question?
I don't have any question. I just wanted to understand if you have not already mentioned it, whether you already have a POC for this design.
The exactly code, source code, or?
Yeah, I mean, any sort of source code that validates this design.
Oh. This should be ready soon, and we can talk about it.
Yeah.
Yeah. So
but
so far we don't have a valid testbed for now, but it should be implemented soon. Yeah.
Sounds good. Thanks. So is there any other question on the kube proxy removal design? It appears that there is quite a lot of discussions going on here, especially regarding this conversation that we had on the source IP, and I'm sure that the conversation will continue probably on GitHub if necessary. If needed, we can also bring it up in the next office hours meeting. So I'm sure there will be much follow-ups to this design. So thanks a lot for sharing it, Hong Liang and Wei Chang. And if there is no other point on this, I think we can move to the next topic on the agenda. Just wait 10 seconds, 15 seconds to verify that we are good on this front.
All right, thanks.
You're welcome. All right, so I think that it's now time for the flow aggregator demo. So I don't know who's going to present, if Zrika, EO, or both of you. So please go ahead.
Yeah, I'll EO will be presenting the demo. I'll just introduce, give a bit of context. So a few months back, we have demoed Flow Exporter, which runs, which connects from every node every node in Antrea cluster to external flow collector. So we developed a flow aggregator, which runs as a deployment in the Antrea cluster. All the nodes talk to flow aggregator, and we do correlation and aggregation, and then send it to external flow collector. So Yongming and Yo had worked on the demo. I'll give the stage to them.
Okay, thank you, Zrika. I will start first. So yeah. Oh, can you see my screen?
Yes, go ahead.
Yeah, thanks. Flow Aggregator is a new feature integrated into our network visibility feature. And in the past, we only support Flow Exporter feature in Antrea that exports connection at agent to an epifix flow collector as flow to sending the flow records. However, in this implementation, we will have two flow records, one from the source node and another from the destination node of a same given connection. So we have added a new Kubernetes service, which is called Flow Aggregator, and all the flow exporter as each agent connect to the flow aggregator and send flow records to it. And the flow aggregator will do a combination and fill out some missing information, also add some statistics into the final aggregate flow records. And then flow aggregator will send the aggregate IPFix records to our external flow collector and do a further more flow visualization using the ELK flow collector. This is a brief framework of our flow aggregator design. For example, there are three or more flow agent, Antrea agent flow exporter, which exports the flow records to the flow aggregator. The first part of flow aggregator is called collecting process, which is used to collect the flow records come from the flow exporter. Then the intermediate process will combine these flow records, fill out some missing Kubernetes infos, and also add some statistic calculation into the aggregate flow records. And then using the exporting process to send out the aggregate flow records to the external IPFix flow collector. This is supported functionalities in our flow aggregator. With most important one is absolutely aggregate flow records by the 5-tuple flow key, which are source IP, source port, destination IP, destination port, and also the protocol. Also, we do some status calculation and add it into the aggregate flow records. Also have as a single stack IPv6 support in both flow exporter and aggregator. And also all the connection between the flow exporter and aggregator is protected by the TLS security. Also some new diagrams and dashboards are added into Kibana, which will be shown in the demo soon. Nice. Yeah, Yo will give a show of the demo setup and also the configuration file.
Yeah, sure. Thanks, Yuming. Share my screen. Can you guys see my screen?
Yes.
Yes, yes.
Yeah. Now I will demo the flow aggregator and its visualization. Here is a setup for the demo. In the configuration file, we enabled flow exporter in Antrea agent and specify the external flow collector in the flow aggregator. TLS in the flow aggregator and in the Antrea agent and the flow aggregator are enabled by default. And we use iPerf to simulate the pod-to-pod and pod-to-service traffic. As shown in this diagram, this is our demo setup for the IPv4 cluster. We have 5 nodes and several pods on each node. There are 7 servers in board front, and for example, for server 1-1, there are 5 clients talking to it. Client 1-1, 1-2, and 1-3, 1-4, and 1-5 to send traffic to it. So we will cover both inter and intra-node traffic here.
Yeah, sorry, quick question regarding it. That's a very stupid question on me. Client 2.1, there are 3 of them. Are there 3 pods on server 2 or they are running on the nodes? Because
yeah,
they are outside of the diagram, so I don't understand where they are.
Yeah, that is on purpose because there is no, I didn't assign any node affinity to it, so it will randomly assign to any one of the 5 nodes.
Okay,
so
thanks.
That's why, yeah, thank you. And the server is actually a service to expose the iPerf server pod. So later in the visualization, you will see server 1-1 in both pod-to-pod and pod-to-service traffic. I also applied 3 ingress network policies and 3 egress network policies to the client and server ending with -1. So server -1-1, 2-1, 3-1 will have ingress, and client 1-1, 2-1, and 3-1 will have the egress network policies. And we have a simplified IPv6 setup. I will show you later. Yeah, let's move to the dashboard. So this is the dashboard. Compared to the last demo, we add the node throughput and the network policy dashboard, and also add some graphs in the pod-to-pod flow and pod-to-service flow. So let's go to the pod-to-pod flow. So before, we have the Sankey diagram to and some line graphs to show pod-to-pod flows. For example, I can filter the flow by the destination port name if I want to use a server 3-1. And it will show the traffic that have server 3-1 as a destination port. And it's worthwhile to mention that in the past, we cannot resolve the remote destination information, like destination port name and namespace. But with integration with Flow Aggregator, the destination information can be filled. So for example, for this web server 1-1, there are 5 clients sending traffic, both intranode and internode. We all have the destination information. Additionally, we add this pod-to-pod flow key to this, to our visualization. It's like a semantic version of 5-tuple, which is composed of the source port name and port, destination port name and port, and the protocol. So there are 4 graphs we newly added. They are grouped by this pod-to-pod flow key. So the left 2 graphs show the throughput and reverse throughput of each flow. And the right part is the cumulative bandwidth for this pod-to-pod flow. For example, if I say this, let me choose one of this orange flow, you can see that it's very stable, has a very stable throughput, and the corresponding cumulative bandwidth will show a smooth growth. Yeah. Similarly to this pod-to-pod flow, we also have the pod-to-service flow here. The only difference is that the destination, instead of using the destination port and the port, we use the destination service name and the service port. So the flow key here, we also use for destination, we also use the destination service and service port. The graph here is similar to the pod-to-pod one. We had the throughput, reverse throughput, and the cumulative bandwidth here. Let's move to the node throughput dashboard. In the node throughput dashboard, first, the flow diagrams are showing the in a straightforward way the traffic between the nodes or internodes, and it also has a line graph to show the aggregated node throughput over time. We introduced the heat map here to visualize the aggregated total ingress and the egress throughput, which is helpful for user to identify like which node will take a lion's share of the bandwidth. As shown here, this node ending with 230 share a line majority of the traffic, and the rest of the nodes are basically having the similar traffic here, as you can see from the darkness of the color. The next feature we have this network policy. The network policy in this Sankey diagram, you can see there are different colors of this flow. The flows are grouped by network policy here. So for these yellow ones, you can, if you hover over, it will say that the ingress policy is NP1-1, and all of them are NP1-1. And this brown one will be the 1-2 instead. So they are color coded. And I can filter the ingress and egress network policy by its name and namespace. If I only want to know the 1-1 network policy, it will filter out. So as I mentioned, the NP1-1 is applied to the server 1-1. So you can see all the traffic, file traffic to the 1-1 are filtered out here. The pie chart here shows the distribution of the traffic grouped by the network policy, and this is a namespace. Yeah, that is basically the network policy. What we need to mention here that we only support network policy that will allow the traffic. The dropped and denied connections are planned to be realized with packed-in the future. Yep. That is IPv4 cluster. We currently also support the IPv6 single stack. The dashboards are similar to IPv4, but with some IPv6 fields. Like in this overview, previously we had the IPv4 address. Now for IPv6, we have the IPv6 address. And in the flow records, we also show some IPv6 information here. Yeah, that is basically what we want to demo for these features.
Many thanks. That was a very nice demo. It was very entertaining to see. Only one question. You mentioned that it's a single stack IPv6. Is this because dual stack will come later, or is there any specific challenge for supporting dual stack?
I think you
yes.
can answer that. Yeah.
Yeah, thanks for the question. Yeah, currently we found that in the dual stack cluster, the flow exporter is failing to retrieve the service, Kubernetes service information. So we are still debugging on this. So we mark it as working on items right now.
All right, thank you.
Thank you.
Any other questions?
A quick question on this. I know you have mentioned that the deny action support has not been yet realized for the full aggregator. So for the network policy that actually has allowed rules, does this work right now for both the Kubernetes network policies and the Antrea native policies already?
I think so. Yeah.
Oh, cool. All right. Thanks.
And I just want to add that we plan to enhance the network policy information with the rule name, and which with granular information about network policy. Currently, we are planning to enhance that part. Yeah.
Yeah, that's gonna be really nice. Yeah, and also I wanted to try to understand, like, since if we wanted to support some sort of like visibility for the deny rules, how would those like actually show up on these Sankey diagrams? Because for the denied traffic, there won't be any sort of like load generated, right? So like it will be, would it be like a very, very thin line in terms of, you know, how the traffic looks, or are we thinking something else here?
Yeah, I haven't think about that yet, but maybe we can show a graph that only have the deny rules.
Okay, makes perfect sense.
Yeah, so
it's just a question that I wanted to throw out.
It's hard to incorporate it in this graph.
Yeah, makes sense. Thanks.
All right. I believe that it's all for this demo. So many thanks to Io and Yoming for presenting it. That have been extremely interesting. And we are now in open discussion. And anything else that you would like to bring for open discussion? Any other topic you would like to bring up? All right, it appears then that we are at the end of the meeting. I would like to thank again today's contributors, and I think we can stop the recording here, and we'll meet again in 2 weeks' time. I just want to also give you a reminder that we now on Tuesdays at 2 p.m. Pacific time, we have the Antrea office hours meeting, where you can attend to either ask or answer any sort of questions that community members might have about Antrea. So thanks everyone for attending, and have a good one.